Noah Vaughter from DIYDSP.com. And I just got back from Miami at 3 o'clock in the morning, so that's why the sunglasses. Anyway, this is going to be the follow-up to my previous video where I was making a bracket to hold an electric eel generator. So if you recall, this was the original generator used on this electric eel instrument, and I messed up accidentally, and I accidentally pulled on this too far and I made this fragile. That's okay, because it's time to step up to a more targeted design, a more reproducible design. So now I have this standard shape that I designed over in Fusion 360, and in my last video you saw where I took it out of the CNC router. And at the time when I did that video, I didn't have the right tool to mount these pulleys onto the generator. So I've got it now. Let's continue and try it out. So first of all, what I'm doing, I'm putting 2 of these little stepper motors that I back drive as generators onto here, and then I'm going to connect them with this belt. And the way that you mount these pulleys onto the shaft is with a little tiny set screw here. This is actually a 1.3 millimeter Allen wrench, so that's the smallest one that I personally own. So then you could just put it on the shaft. Oh, whoops, I almost forgot. You have to poke it through there before you attempt to mount it, because otherwise it won't fit through anymore. So now that that's on there, let's get in there, tighten that up just a little bit. Okay, it only uses 1 set screw because this is a D-type shaft on the motor, which means its profile looks like a letter D, which means it has 1 square or 1 flattened edge, and the set screw goes against that and holds tight. So loosen that. Okay, that one's out too far already. Okay, so now that's on there tight. See, I can't get that out of there. And by the way, I found when I took that off the CNC, it was just a little bit too small, so I had to get some 200 grit sandpaper and expand it just a little bit. So that's good feedback. When I make my next one, I'll be able to expand the size just a little bit larger. My friend told me it's because the wood compresses. Now you see this first motor here locks into place. There's a spot for 4 screws. I only have 2 with me, and I've got washers on there, so that one can't move. Then this one, in order to take the belt on and off and possibly adjust for having different size pulleys, this one can slide back and forth just a little bit. So next I'm going to put the screws in place, and I'll just make them finger tight. There we go. That's the first one. There's the second. Now those aren't very tight. I can still slide that back and forth. Let's put the belt on. So for those interested, if you want to make your own, that's a 1 millimeter belt, by the way. So it just fits over just with plenty of slack there. And if I pull it tight, there it goes right about to the middle. So now that it's in place, I'm going to tighten down the screws. There we go. So now it should have a pretty good tension on there. It's spinning both of those. I pluck it, it vibrates like a rubber band. So we're back driving stepper motors as generators to make electricity. Let's try it out in the actual instrument, all right? So this here is the generator electronics. It's a pair of AC voltage doubler rectifying circuits. which is, if you're familiar with a bridge rectifier, almost the exact same thing. The only difference is that it uses 2 fewer diodes. So a bridge rectifier uses 4. This one only needs 2. So there's a little bit less loss there, which is nice. But the really sweet advantage is that it doubles the voltage, where in this design, it's really preferable to have a higher voltage in order to drive the amplifier circuit. All right, so now that that's on, let's try out the instrument. Now notice I haven't mounted this yet, so I don't exactly know how it's going to mount. So I got this bracket so I can just crudely lock it in place, so it won't go flying when I touch it. All right, you ready? Here we go. Ooh, yeah, okay, that's fired right up. In fact, I think there's so much power there, it's actually overdriving it and shutting it down. Woo! Yeah, maybe if I find some other settings on this knob board here, it'll use the power a little differently. Oops. Okay, wow. So that's a good thing. That tells us our generator is working, and in fact, it's working so well, it's overdriving. I'm not sure. I'm going to have to analyze that, but that'll be another video. So thanks for watching. If you have questions about how the generator works, how the doubler circuit works, etc., go ahead and ask me in comments, and I'll do my best to explain it to you. It's not a terribly complicated circuit. Definitely subscribe to this channel. Go back and watch all the others if you haven't seen how we got to this place. I think one of the next steps is I'm going to mount this keyboard permanently on here and just try to get everything in one place. You can see the guts are completely out of the instrument. When I built this years ago, it was a very, very rushed job. So I didn't know how to use CAD either. So everything was just kind of mounted and resting inside there. It wasn't a very formal design. Now that I've got some experience playing and designing and everything behind my belt, I'm going to figure out how to make this a really solid thing, the type of thing that I could ship overseas or send a musician out on tour with for 6 months of the year and not have it break. So I know for one thing that's going to include some of the very delicate wires that are just floating on this keyboard. And you can also go to my wiki, exertion.pbworks.com. That's like peanutbutterworks.com. That's a free wiki where you can just see all of the components and designs and deeper explanations of how the thing works. All right, thanks for tuning in. Adios.